Hey you folks, Quillian here, and welcome to another Unity tutorial where we make a 2D physics game about, I don't know, let's say stacking boxes. Right now we're at the point where we can do kind of cool dragging things, objects interact with one another, and so on and so forth. But especially with the triangle, it's really obvious that this line that we're drawing is not, it's not like the object is physically connected to this line, and it might feel a little bit weird, especially with a triangle. Also, it would be really nice just from a gameplay point of view if we could grab, say, this corner over here and then use that to flip the object over. So far, what I've been doing is sort of nudging objects against one another to get them to rotate, which, I don't know, might be the one way you want your game to work, but I don't know if that's what we want in this particular scenario. So what we want to do is these forces, we want to apply them to a specific spot on our object. And there's a couple of different ways to do that. Instead of setting the velocity, we could actually be applying forces to this object. And one of the things we could do is there's a function called apply force at, which allows us to apply the forces at certain places. But I think that might get a little bit too technical and a little bit hard to work with. So instead what we're going to do is utilize springs, which is a really great way of getting the effect that we're looking for. First thing, that I'm going to do is I'm going to first make sure I've applied all my changes to my box. And I'm going to get rid of the box. I'm just going to work with the triangle for now, just because, again, it's the one that's the most obvious about what the problems are. So on our triangle, we're going to go ahead and add a joint. Now, there are a variety of different joints available in the game, in Unity, both for 3D and 2D objects. I feel very strongly like the one we're going to want is probably the spring joint. Distance joint is also a possibility. Let's go ahead and test the distance joints really quickly right over here. So our distance joint is here. It's got an anchor. This is on our object. This is the place where on our object we are anchored to. Let me go ahead and just reset that to 0. And then the connected anchor, which is what it's sort of connected to, right? So the anchor is where on the object this joint is, and the connected anchor is where on the other object it is. It requires, or can have, a connected rigid body. This is if this is linked to an actual other rigid body somewhere. If this is left to null, then this anchor here, or this connected anchor, will simply be fixed in world space. It's like it's attached to, I don't know, the sky or something like that, right? So if you're trying to make a chain, for example, then you might want to have a bunch of rigid bodies connected to one another. But here, for our testing, this is going to be perfectly fine. If I go ahead and hit play, we'll see what happens. We have a distance of 1. This forces the object to be, forces the length of this joint to be 1. And now we're kind of dangling here. If I go ahead and I move, say, the connected anchor, you can see it's pretty obvious what starts to happen. Wow, we get quite a bit of spin there, which is kind of interesting. There, it'll eventually settle down. We could also, let's put in a little bit more, put in a little bit of drag, angular drag as well. It'll help slow down the wiggle woggle. We can also move the connected anchor. This will be the point on the object here where this anchor is connected. Actually, I'll go ahead and pause, or I'll stop the play. That way I can manually, let's move, no, we're going to leave the connected anchor there. We're going to move the anchor point to this corner over here. Now if I hit play, you can see we're now dangling from that corner, which is pretty cool. There's a little bit of weirdness here. Why is this object going into the ground again? Honestly, I feel like this object is, this variable here is really oddly called. This is basically if objects that are connected together via joints can collide against each other. Well, I'm not connected to any object. I'm just connected to the background, so I would still have expected the collisions to work, but apparently not. We have to turn this box on. So if we go ahead and check that, and then hit play, our triangle will once again collide with the world. And then if I take the connected anchor and sort of move it up, there we go, move it down, move it up, move it down, we can get things to kind of work. You get a bit of a weird sort of jerkiness to it, but we maybe are moving things in unexpected ways. I don't know. Now, I'm not a huge fan of the distance joint, which keeps a fixed distance. Although, if we did turn the max distance only, then it will no longer enforce the situation where we're too close. I don't know. It's weird. I'm not going to be happy with the distance joint. What I want is a spring instead. So I'm going to remove this component, and we're going to add the spring joint 2D. I think this is going to feel a lot better. Let's go and reproduce, well, we'll just hit play right now. We'll turn on the collide connected, because certainly we want that. And now there's a bit more of a springiness going on here. And if we move the connected anchor around, that might be okay. It might be a little bit too bouncy. What we can do is we can add, first of all, a little bit of damping, which will sort of slow down some of the bounciness. And if we increase the frequency a bit, it'll sort of spring back a little bit faster, but it's more responsive. Like basically it springs 10 times per second instead of once per second. And that means it'll sort of find its way a little bit faster. Oh, and we definitely need, I did this while the game was playing, so I didn't save it. We definitely need some drag, both linear and angular, because otherwise there's no air resistance, so it doesn't sort of start slowing down when we move things around. Now if I do this, it'll start to settle a little bit faster and just feel better. So why am I doing all this? Well, the idea, well, again, if we move the actual anchor, we can anchor to a different place on the triangle, like that. All right, and that's the real win. So now we can pull it from a specific corner, especially if we shrink the distance down a little bit. Something like that. Now imagine this connected anchor is our mouse. So now we can get the object to dangle from our mouse in a way that might feel very satisfying. I think it'll ultimately be a bit better. We can try different things. We can play with different possible solutions, but there we go. So what we're going to do, when we click on an object, let's open our mouse manager. When we click on an object, come on, load, there we go. We can grab the rigid body, I suppose, but instead of changing its velocity, what we're going to do instead is add a spring component. This spring component that we added to this triangle, we're going to add this. When we click on the triangle, we're going to add a spring. As we move the mouse around, we're going to move the connected anchor around. And then when we release the mouse, we're going to remove the spring joint. And that's all there is to it. And I think, I haven't actually tested this yet, but I think we're going to get an experience that will feel a lot better. Again, it will depend a lot on what kind of game you're trying to do. So we're going to still have our grabbed object, but we're also going to have our spring joint 2D that we're going to create, destroy, and also update every frame. So we'll call this the spring joint, I suppose. And it will start off null. Again, I'll make it really explicit with this. The other thing we need to track is really the where we clicked on the object. Although I don't think we need an actual variable for that because our spring joint will sort of kind of have that. Okay, let's go ahead and do this. So we are still going to grab the object. We are no longer going to turn off gravity when we grab it. I don't think we want to do that anymore. We're not going to turn off gravity. Oops, I got to embiggen this. Sorry about that. We're no longer going to turn off gravity because gravity is still going to be there. Instead, we're going to create a spring. So we're going to grab our object, and then on our grabbed object, we are going to add a component. Grabbed object.game object, add component, spring joint 2D. And this will actually return the new component like that. So then we can make some settings. So the spring joint that we have, we need to make some changes to it. There's the anchor and the connected anchor. So set the anchor to the spot on the object that we clicked. Does that make sense? So basically, if I click right here, right here on my triangle, that's where I'm going to want the anchor to be. I'm going to want the anchor to be there. If I click there, I want the anchor to be there. Now, it's important to note that the anchor is in local coordinates, so we're going to go ahead and have to figure that out. So the spring joint.anchor is just a vector, right? I don't think I'm lying. Anchor, yeah, it's a vector 2. So there's an x and a y that's got to be set for this. Or we can just say new vector 2 with some coordinates. So our hit object has information. In particular, it has information about the exact point at which we clicked. Now, what I can't remember is whether the hit is in local coordinates or global coordinates. So I'm going to do a quick search of Raycast hit 2D, the documentation. Drag this over here to show it off. So the point, that's the point in world space. Okay, so the hit.point tells us exactly where in the world the actual hit happened. Well, we need those in local coordinates. We can figure that out pretty easily. grabbed object dot transform dot inverse transform point. Big words, but what it does is it takes a point that's in world coordinates and turns it into local coordinates. Easy peasy, which is where we're going to set the anchor. Now, the problem, we can't feed it directly in like this, because the problem is the transform inverse transform point actually returns our information as a vector 3. In fact, there's like a bunch of like weirdness going on here because we're feeding it a vector 2. But I think a vector 2 will automatically upscale to a vector 3. I might be wrong. We're going to figure this out though. So vector 3 local hit point equals that. And then this has to be a vector 2. Actually, does it just auto convert from one to the other? We're going to find out if we get any compile errors right now. Let's find out. Unexpected. Result comparing with null is true. Oh, hit can never be null because of reasons. I see. Because it's not a nullable data type. It's a basic type, like the vector 2 or vector 3. Interesting. All right. No worries. Mouse manager.springjoint is assigned a value, but it's never used. Isn't it, though? Ah, my bad. Here, we're creating a new variable. This is a local variable called springjoint. We're actually not using the member one. It's nice to have that warning, actually. So we actually want to make sure we're setting the member variable to this new component. Then we're going to figure out the local coordinate where we clicked and do that. Apparently, it's auto-converting from vector 2 to vector 3. So that's nice. We're going to set the anchor to where we clicked. And okay, that's step 1. Then, when we release the mouse, one of the things we have to make sure we're letting go of the object, but before we let go of the object, we want to remove there's no remove component. Instead, what you do is you call destroy. We can destroy the spring joint. And I think that will remove it. Let's do a quick test. This won't quite be in a functional state. Let's remove the spring joint from the triangle. We're going to hit play. I'm going to click the triangle. We'll get it over here. It'll add a spring joint. When I let go of the mouse, it'll destroy it. Good. Okay. So we've got that. Now the spring joint is not in the right position yet, but we're adding it and getting rid of it. And also, we can confirm that the spot where we click is where the spring joint is being anchored. Lovely. See that? Wherever we click is where the spring joint is forming. Good. Okay. So the next thing we want to do is we have to update the connected anchor, because here when we click, the connected anchor, which is the bit that you're seeing up there, is not moving with the mouse. So we want to move the connected anchor to the spot where the mouse is. We can do that. Now, where do we want to do that? I think I'm going to want to do that as the update, because I want it to change the anchor point as soon as the update changes, as soon as the input changes, which is during the update, and then on the next physics loop, it will use the new anchor point. So if our spring joint is not equal to null, and actually after we destroy the spring joint, let's go ahead and set this to null right away. So if the spring joint is not equal to null, if we have a spring end, then we want to update the spring joint.connected anchor to be equal to the position that the mouse is in world coordinates, but with the, yeah, we want to use this, but the 2D version that's lined up with our sprites. So we're going to take the mouse position, we're going to convert it into world coordinates, we're going to 2Dify it. So the connected anchor is going to be there, except, oh, not quite. We have to make sure, and it's very important, that it is at the same thing, the grabbed object inverse transform point, because we're going to go from a world coordinate to a local coordinate there. So we go from the screen coordinate system to the world coordinate system to this. Actually, since this becomes 2D here, I think we could skip a step. I think I can feed it in the 3D position. It'll convert it to a local form, but when we assign it here, because this wants a vector 2, it'll drop the Z component no matter what. So this should work. Let's see. Well, it's moving it, but not in the way I expected it. Let's make another quick change. The fixed update here, we literally have to do nothing here because we were doing all this to set a velocity. We don't need to set a velocity anymore. We're simply going to have the object move based on the spring. Why is the... Hold on. That doesn't make any sense. The anchor is probably supposed to be in world coordinates. Because, like if I click here, you can see right now in the inspector that the connected anchor and the anchor are basically at the exact same coordinates. I think the connected anchor, because it's not attached to anything, it must be using world coordinates. So we don't have to do an inverse transform point. We can just tell it be anchored to the mouse position in world coordinates. And again, it'll auto convert from 3D space to 2D space. Okay. Yes. But why is it not working? We got a spring, we have a distance. It should be springing up. Is that looking strange to anyone else? Okay, it's updating if I do that. Why is that not working? Now, ignore the fact that my drag line is not here. Our drag line, let's make an adjustment here. It's going to be looking to see if it's a spring joint, and it's going to use the spring joint.anchor.x and the spring joint.anchor.y, and then it's going to use the spring joint.connected anchor.x and connected anchor.y. But. Right, the anchor is in local coordinates, so we need a world version. We don't need the mouse information at all in here. What we do need is a vector 3 local world anchor equals grabbed object dot transform point. This is going to go from local to global, and it's the world anchor dot x world anchor dot y that we do this. So now our drag line, is exactly the same as the spring. Like you can see some of the spring stuff over there. Let's go ahead and just not enable. We won't enable the drag line. So only in the editor are we going to be able to see the drag. Is there something weird? All right, after a brief pause, I have figured out the problem. Now, if we go ahead and hit play, this is going to be a stupid problem. That's very annoying. We're back in the state where it's not currently working. I've got the spring, but nothing is actually happening, despite the fact that everything here seems to be set okay. Connected rigid body, none is fine. Collide connected, well, we will want that on, but having it off, it should still spring. It should just be passing through the surface. It's just the spring is literally not doing anything right now. If we go and this line, even though the connected body was already set to null, if we explicitly set it to null, watch what happens. Now it works. Look at that. Like magic. Now all of a sudden our spring is functioning and everything is awesome and right with the world. It should be noted that, well, first of all, we're still passing through stuff because the collide connected is turned off. We will want to turn that on. You'll note that despite the fact that I'm doing all these other tweaks, none of these other tweaks was enabling it. However, I did discover that this line here, which turns the collide connected on, if either this or this gets set. That's enough to wake up the spring. For example, if I comment out the second box over here, now the spring is turned on and it collides. So the moral of the story is we have to do either set collide connected or set connected body even to null. Even if you're only setting it to null, you have to do one of those two lines to actually wake up your object, which seems mind-bogglingly bizarre. Enable this if you want to collide with objects still, and you probably do. This will also wake up the spring. Actually, let's capitalize some of these letters. Wake up the spring. And then over here, this will also wake up the spring, even if it's a totally redundant line, because the connected body should already be null. But what it means is like one of those things has to happen for the spring to be like, okay, I guess I'll start operating now. So at this point, so that second line at this point is truly redundant, but this way it gives us the option of not enabling the connection thing. Now we can swing this around. Note, if yours like swings around in kind of a crazy rate, just make sure that you've got a little bit of linear drag. If I go ahead and turn off that linear drag, for example, and I start spinning this around, I find that it's just a little too spinny because there's no sort of air resistance slowing it down from spinning it like that, which is no good. I quite like the one, and the angular drag. The angular drag is the thing that stops it from sort of literally like spinning around itself that way. If I turn that down to say 0, for example, and I grab the corner, or maybe not the corner, but maybe more in the middle, we can get in the thing. It doesn't really show up as much with the spring connected. But it's that sort of thing, that spinning in the air, which we may or may not want to have it slow down. Actually, I don't know. What if I put it back to 0.5 and try to do one of those flings? What do we want? It slows down the spinning a little bit over time, and I think just makes everything a little less crazy. But the linear drag is really important, so that if we do swing things around this way, and then I stop, it'll sort of slow itself down properly. You may want to tune some other things, the distance, the damping ratio. The damping ratio determines sort of how much it might spring up and down. If I set the damping ratio, for example, let's turn this off. Let's set the damping ratio to 0. You may or may not prefer it that way. All right, and we can go ahead and grab it. You can see it'll be sprawling up and down a little bit more. Although, because we have linear drag, it's actually not going to spring quite as much as you might imagine. So tune the settings. Tune the settings until you get to a number that you're quite happy with and that you can work with. The distance, the damping, the drag, all those things, you'll get somewhere that you quite like. So now that we've got that, we'll unpause. We could bring the box back in. I'll set the box to also have the linear drag of 1 and the angular drag of 0.5, just because that seems like a pretty good number. Go ahead and unpause, grab the box again. We should still be able to sort of kick things around. And there we go. And we can even grab the box from a corner. So I'm going to end this episode, which has been slightly longer because of some of the glitches that we had. And in the next episode, I think we'll just work on having the boxes sort of spawn so you can stack them up one on top of another, and then we'll end it there. I'll show you how to make a trigger so that if a box falls into it, it'll be destroyed, because right now it's just going to keep falling until eternity. You know, we can watch its coordinates over here. It's just falling from the sky. So a trigger to maybe have the boxes destroyed if they fall down, but also that could be your lose condition. The way I imagine it is boxes and things in different shapes are being thrown at you, and you're trying to stack them up on top of this platform, trying to get as high as you can for maximum points. But if anything falls off the edge, game over. You got to restart. And I think that would be, you know, kind of a cute, adorable, kind of maybe even fun kind of game. Imagine that if we actually get a little bit of fun out of this. See you next time, folks. Bye-bye.